In section 2, we are going to start talking about exponential functions. So it's best to start with what is an exponential function. So an exponential function is an equation where the variable appears in the exponent. So typically we write an exponential function as f of x equals a times b to the x plus c. And b does have to be greater than 0. So your base number can never be negative. So an example of something that would be an exponential function is f of x equals 1/2 to the x, or something like y equals -7 times 2 to the x plus 3. So I can't have a negative in an exponential function, but it has to be through that a value, so that number in front of your number that has the exponent. Okay. Next, we want to talk about domain and range of your exponential function. So to review, domain is your possible x values. So you think to yourself, is there anything I can't plug in for x in an exponential function? And the answer is no. So the domain is all real numbers, which we write using interval notation, and we say the domain is from -infinity to infinity, because I can plug in any number in for x in an exponential function. There are no restrictions. For the range of an exponential function, that is all possible y values, which the range is different for every exponential function depending on its equation. So the way we typically identify the range is always c, infinity. So whatever that constant is that you add or subtract at the end of your exponential function, that is going to determine your range, because you're never going to have anything smaller than whatever you're adding and subtracting at the end. So c could be 0, c could be -15, c could be 2. So whatever number you add and subtract determines your range. So for our first set of examples, we're going to determine whether or not the function is an exponential function or not. So when you're looking for an exponential function, you're looking for your variable x to appear in the exponent. So we have y equals 3 to the x plus 4. So my variable x is in my exponent. So this is an exponential function. So the answer is yes. My second example is y equals x squared minus 10. This is not an exponential function. We just talked about these in Module 4. This is a quadratic. It's specific when your variable is squared. So your exponent is specifically 2. And then the last one, y equals 4 plus 2 times 1/2 to the x. Again, my variable is in the exponent, so this is an exponential function. We also want to determine the domain and range of our exponential functions. And the nice thing is you can determine domain and range without graphing an exponential function. You never have to graph an exponential function to determine the domain and range. So for the domain, every exponential function has the same domain. So y equals 2 to the x has the domain -infinity to infinity. For my range, I look for what number am I adding or subtracting, and I'm not adding or subtracting anything here. So my range is from 0 to infinity. Y equals 1/4 x plus 1. My domain, -infinity to infinity. For my range, I am adding 1, so my range is from 1 to infinity. And the last one, y equals 2 times 7 to the x minus 3. My domain, negative infinity to infinity. My range, I'm subtracting 3, is from negative 3 to infinity. So again, no need to graph these to determine domain and range. You are always just domain negative infinity to infinity, and then range whatever number is added or subtracted to infinity. Last thing we're going to discuss are horizontal and vertical asymptotes. So we talked about these when we're talking about rational functions. It's actually a lot easier for an exponential function to determine its horizontal or vertical asymptotes. So when we talk about vertical asymptotes for a exponential function, the vertical asymptote comes from whatever values you can't plug in for x. And because our domain is negative infinity to infinity, and there's never a value you can't plug in, there is no vertical asymptote. So anytime you are asked the question, what is the vertical asymptote? It will always be none. The horizontal asymptote, there will always be one. So just like with a rational function where we either had a vertical or a slant asymptote, a horizontal or a slant asymptote with our rational functions, there will always be a horizontal asymptote for an exponential function. And the nice thing is, it is always y equals c, because horizontal asymptotes go in with your range. And because my range is always determined by that value I add and subtract, that is also where your horizontal asymptote is going to occur. So whatever number you add or subtract, that is also your horizontal asymptote. So our same examples from above, we are going to now identify vertical and horizontal asymptotes. So for y equals 2 to the x, my vertical asymptote is none. My horizontal asymptote, I do have to write as y equals. It is a horizontal line, so you must have y equals, and then it would be 0. It is never none for a horizontal asymptote. So y equals 1/4 to the x plus 1. My vertical asymptote is none. Horizontal asymptote is y equals 1. And for the last one, y equals 2 times 7 to the x minus 3. Vertical asymptote is none. Horizontal asymptote is at y equals negative 3. So very easy to determine the domain range and vertical and horizontal asymptotes of an exponential function. So let me know if you have any questions on how to do that.